We're going to start on the front side here with number 1. It says describe the transformation that would occur to the parent function f of x equals absolute value of x to arrive at the new equation f of x equals absolute value of x minus 1 minus 4. Okay, so what we have to, actually, I don't want to do this on the PDF. Let me open the Word document of the review so I can write on it. Here we go. All right, so I'm going to write at the top of the review. What we have to remember is our equation. A is multiplied in front of the absolute value bars. H is subtracted inside, and K is added outside. Excuse me. And we also have to remember what A, H, and K do. Doesn't help us to know where A, H, and K go if we don't know what they are. So you have to remember that HK is your vertex. That might be the first thing I write down. When I get my scratch paper on the test, I might just write vertex HK just to remind myself. Okay, and then your slope, and I'm going to put right, the right side of the V, the right side of the absolute value function, slope is that A value. Okay, so remember A is going to vertically compress or stretch your graph. It could reflect it. H is going to horizontally shift your graph left or right, and K is going to vertically shift your graph up or down. All right, so here we can see inside I've got -1, and outside I've got -4. So I know that my H is and K are the, H is the opposite, K is the number on the outside. So H is the opposite of -1. So H is +1. It is shifted right 1. K is the number on the outside, so -4, -4. So that is shifted down 4. So this graph is translated or shifted right 1, down 4. It didn't ask for this, but I'm going to go ahead and write. That means the vertex is at 1, -4. Okay, the A value is an understood 1. So that means it has not been vertically stretched or compressed or reflected. A is 1 in the parent function because nothing's here. It's an understood 1 right there. Okay, and nothing's changed here. Okay. In number 2, we want to graph the function. So I'm going to identify the same things I just did. Now this time my A is not 1. My A is a -1. So it's not stretched or compressed because it's still 1, but it's negative. So that means it is flipped or reflected over the x-axis. I already forgot which color I used up here. Oh, red inside, pink inside. Okay. Then blue outside. So this tells me my, oops, supposed to be on a pen here. This tells me my H is +3, so that is right 3. And my K is +2, so this is up 2. So this means that my vertex is at 3, 2, because it's HK. So I'm going to plot that first. I'm going to go to 3, 2. And then the green is my slope, or the A, I wrote it in green, is my slope to the right. So it's -1. So instead of going up 1 over 1 and my V opening up, I'm going to go down 1 over 1. My V is going to open down. So there's the right side of my absolute value. And then I just have to reflect that over to this side. So it was reflected over the x-axis. It's opening down. I know it's opening down as soon as I see that that's a negative. I immediately know it's upside down. Okay, and then it's been shifted right and up 2 from the 0, 0, where the vertex starts. Okay, let's try that again with this one. Okay, what is A here? If nothing's here, it's an understood 1. So A is 1, which means it is not reflected because it's not negative. It's not stretched or compressed because it's 1. So our slope is going to be 1, just like the parent function. Okay. My K, there's nothing added or subtracted on the outside there. So what does that mean K is? It's nothing, it's 0. So this hasn't been shifted up or down either. So the only thing happening here is this +2 on the inside, which tells me H is -2. So that is shifting left 2. So my vertex, because K was 0, my vertex is at -2, 0, because it's at HK. So -2, 0. So I shifted left, but not up or down. And then I have a slope of 1. So up 1 over 1 for the right side of my absolute value. And then I reflect that over and have my graph. All right, number 4, it says Rose was asked to transform the graph of the function f of x equals absolute value of x by reflecting the graph over the x-axis, making the graph making the graph a vertical stretch. She wrote the function 2 times the absolute value of -x. Did Rose meet the rule? Why or why not? All right, so first of all, they're saying that Rose is made A2. So is that a vertical stretch or compression? When A is greater than 1, because it starts out as 1 in the parent function. So we're always comparing to 1. If A is greater than 1, or if A is between 0 and 1. Those are the two things we're looking for. Okay, which one makes a stretch? When A is greater than 1, because remember A is your slope. So if my slope starts out as 1, rise 1, run 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, but if I change it and I make my slope 2, I'm getting steeper because I'm saying rise 2 over 1, rise 2 over 1. Okay, so my slope gets steeper, so it is vertically stretching. Okay, it looks narrower or taller. Okay, where if I make my A value less than 1, something like 1/2, okay, I'm saying up 1 over 2, up 1 over 2. So I'm making it less steep. I am compressing. I'm going to color code this. So that was So that's the rule you need to remember right there for A. If the A is bigger than 1, you are vertically stretching the graph. You're making the slope bigger, so it's steeper. Okay, if you want to see it as an actual absolute value, I'll finish it out. See, it looks narrower, taller for the purple, and it looks wider or compressed for the orange. Okay. So let's see, did Rose do that right? Does that answer their question? Let's go back and answer this. So A is 2, which we're saying that would be a stretch, and that's what they asked. So that part checks out. Yes, she did the vertical stretch part correct. But with this negative on the inside here, is that how you reflect the graph over the x-axis? What did we say up here in these? I think it was number 2. We reflected over the x-axis. Where was the negative to reflect over the x-axis? Where was that negative? It was outside the absolute value bars. Rose put her negative inside the absolute value bars. So that is incorrect. Okay. So she should have written it. The 2 was good, but the negative needed to be outside. So it should have been -2 times the absolute value of x. Okay. So the answer there is no, because she put the negative in the wrong spot. Okay. Having the negative on the inside is going to, anything inside, remember I've talked about this, inside affects the x. So that would have, if you change your x value, your x axis goes left and right. So that is the reflection left to right that crosses the y axis. Okay. Anything on the outside affects the y. So if your y axis goes up and down, you're reflecting vertically, you're crossing the x axis. Okay. So that negative needed to be outside to reflect over the x axis. All right, let me see how much time we have. Yeah, I'm going to keep going in this one video. So 5 says the parent function is transformed to create g of x, which is -1/2 times the absolute value of x minus 1 plus 1. Describe all the transformations that took place. So we just got through saying that A, when it's negative, what happens? It reflects over the x-axis. And then when it's half, that's less than 1, it is a vertical compression. So those are the effects of A being, label that A. A being negative reflects it over the x-axis, and being 1/2 makes it vertically compressed. Okay, and then we've got H is +1, because remember it's the opposite of what you see here. Okay, so that is actually to the right 1. So a shift right 1. And then K is what's added on the outside, so it is +1 as well. So that is up 1. So this graph is shifted right 1, up 1. It's vertically compressed, and it's reflected over the x-axis. All right, 6 now is getting into solving. Okay, what are all the possible solutions? So step 1 is isolate the absolute value expression. So this right here, if you want a highlighter on the test, I'll let you borrow a highlighter if you don't have one. We're trying to get that by itself. So when I was going over the FA with you, I told you we have to move anything added or subtracted first, and then we'll multiply or divide anything that's a coefficient. So we're going to get rid of this -4 first by adding 4. Now we're going to get rid of that negative out front. That's an understood -1. So we're going to divide out that -1 because that -1 is being multiplied by the absolute value. So that gets rid of the negative, and a negative divided by a negative is a positive. So knowing that it's equal to a positive, I immediately know there's two solutions. So if this was multiple choice, I could eliminate any answer choice that said no solution or had only one solution. Because I know it's equal to, once I isolate and it's equal to a positive, I know there's going to be two solutions. So then the next step is to take what's inside and set it equal to the positive number, or it could be equal to the opposite, the negative number. So +3 and -3. Then the next step is to solve. So to solve this for x, I'm going to add 1. I'm going to do that on both of these. So I get 4 and -2. And again, I know I talked about this with the FA and in our notes, but I'll say it again. Your solution, your answer that you end up with can be negative. It's here when we isolate the absolute value expression that cannot equal a negative. Okay, your solutions that you end up with can be negative. That's okay. All right, what are the possible solutions here? So I need to isolate the absolute value expression. So the first thing I'm going to do is there's nothing added or subtracted outside. So I'm ready to jump in with the division. So I'm going to divide out that -2 that's being multiplied here. So I get the absolute value of x minus 3 equals, and then a positive divided by a negative is a negative. 2 divided by 2 is 1. So at this point, I need to ask myself, is there going to be two solutions, one solution, or no solution? This is set equal to a negative. I have no solution. There's nothing that I could take the absolute value of and get a negative. That's not possible. So I can stop there and just say no solution. All right, number 8, also finding solutions. So I want to isolate the absolute value expression here. I'm going to first move the number being added or subtracted. So that +1 is going to be subtracted. Then I'm going to divide out the coefficient. In this case, that's a 2. So that is a positive that it's set equal to. So I immediately know there are two solutions. So I'm going to go on to my next step, which is to set the inside of the absolute value expression equal to the 3, or it could be the -3. Then I am ready to solve. I'm going to add 5. So I get 8 or 2. So two solutions on that one. All right, last one. What are all the possible solutions here? Absolute value expression. This is what I'm isolating. So I'm going to solve by adding 5. -5 plus 5, that cancels. Or it eliminates. It's just a 0. So I've got the absolute value of 4x minus 8 equals 0. So I know right away, because I isolated my absolute value expression and it's equal to 0, I know right away there is only one solution here. I'm not going to have two answers. I'm only going to have one. So I'm taking the inside and setting it equal to 0, because I can't set it equal to +0 and -0 because 0 doesn't have a sign. It's just 0. That's why there's only one solution. So then I'm going to solve for x by adding 8 and then dividing by 4. And that's my one solution. And remember, you can always check your solutions by plugging them in to the original. So if I took this 2 and I plugged it in up here, 4 times 2 is 8. 8 minus 8 is 0. The absolute value of 0 is 0. Minus 5 is -5. It checks out. And you can do that with all of your solving ones. Okay, you can do that with multiple choice questions. If you forget or get stuck on your solving for some reason, plug your answer choices into the absolute value equation and see which ones work. Okay, that's always an option. Now, if it's not multiple choice, that's not an option. You have to actually be able to solve this. Okay, but again, eliminate possibilities by knowing if there's one solution, 2 solutions, or no solutions. Everybody good? All right, and that's your review.